Okay, so now I'm working on the bottom part of the PCB. The LED fuse indicator is a little weird, but let's see if we need to keep changing the stuff. Basically, it's already connected correctly. I try to avoid the having the enough clearance between the traces and stuff like that. So I think this should be fine. The only thing I don't like is that the resistor here is not gonna be aligned with the other one. So I try to keep the alignment the best I can. But since this is a 2 watt resistor, the measurement is about 12 millimeters. So I really check on on oh, okay, it's okay. Mouser Electronics. I should save. I forgot to save the component part number, so it's okay. Let me how you call it? Mark that out. I would like to have them to be in the other position, but this might be difficult. I think I can still move this resistor to the right. I think I can do that. I don't think it's gonna be affected by this, so let's do that. I'm gonna move it. Let me use the rubber band. 1, 2, 3, 4, 5. Oh, there you go. There you go. All right, I like that. There you go. I think that's not gonna be affected here. The distance here is okay. Track clearance. Need to have 1.5. Oh, that's fine. That's fine right there. Okay, so now both are the same. Yeah, I don't think it's really needed to have the way too symmetric. The most important part here is to have a correct connection. Both they are gonna look different. They are gonna look different. The top and the bottom, they will look different. So there's nothing we can do to fix to remedy that. So as long as the connection is correct. So we'll keep checking. That's why I'm making these videos as a reference. I will keep checking the bottom. So let me see from the. Okay, so let's start with this one here, this area. I'm gonna concentrate on this area. Let me put the ellipse circle here. Gonna concentrate only on this area, and then I will do the other area concentration. So I made it thicker. Okay, let's concentrate on this. It's always a way. Fill color, pen style, pen color. Let's go with the pink. There you go. So I will concentrate on this. All right, let's see. Okay, so let's start with the. Should make it bigger, right? It's okay. R19 is a 2 watt resistor. That's the first okay component. Let's look for the product. LED passive component resistor and through hole resistors, and then I will check for 6.8K 6800 ohms. I'm getting closer to 6.8. 6.8, there you go. And I need one that is 2 watts. There you go, we got 2 watts. And the width, let me see the length. One that I think is 12 millimeters. It's this one here, 12 millimeters. We got 8 of them. Okay, I think this is the one that I choose. This is the one. Panasonic. This Panasonic. Copy. Okay, so it's 12 millimeters in length, and I made the macro sort of like according to the measurements. Let me update the component. Paste. There you go. And let me see the measurements. We have here 12 millimeters, so it's good to go. This is good to go. All right, now I'm gonna copy the manufacturer part number. Since I know that this is the same one as the top one, I will just copy this one here. Copy. Okay, and then I will go up, and so I can update this one here. Paste. This is a 2-watt resistor. Hey, this is a wire. Let me see what material. Okay, Panasonic metal oxide film resistor. Metal oxide resistor. Voltage rating 700 volts. Bolt. Sound like a bolt. It's not a bolt. It's volts. Okay. All right. So we got that, and let me continue checking the connectivity here. The creepage clearance. I think this one here I don't like. Let me see if I can do something to avoid these trays for being there, unless I can move the trays here so we can. Yeah, I think I should do that. Let's make it. This is 0.60. All right, now I'm gonna connect it like this. Yeah, I think it's a problem with the. So to avoid actually having these trays away from the other connection, I think this is fine right here, unless depending on the situation. I'm trying to keep the traces with a good clearance. Maybe Mr. SD is gonna adjust it later. So at least I made the connections today, so let me see. Oh no, that's not good. That is not good. No good. No bueno. Okay, let's see. Okay, I gotta move this down a little bit. Gotta move it down. Okay, let's see. And here, green and green. Come on, green. There you go. We got green. So I need to adjust this one here, and that's fine right there. Okay, we got that. All right, let me see the connections. Continue checking the connections. So we have a diode A, center diode. It goes to ground. This part of the diode. So let's check that. Diode 8. It goes to ground. Let's check the test. This is the ground. Okay, yes indeed, that's the ground. So we check that. Okay, this is good. Now we have one connectivity from here, so it will feed R3. So let's check that out. So this connection right here, it will feed R3, and then the R3 is going to feed the emitter of Q2. Let's check that out. Yes indeed, it's like that. Correct. It's correct. All right, we got that connection. That one, I think this is a really simple connection, this one here. Okay, now we need to see that the cathode of the LED 1 is connected to the collector of Q2. All right, let's check that out. Diode LED 1, it is in fact connected to the collector of Q2. There you go. and the anode is connected to ground. Basically, let's see, this one is ground. Yeah, it is in fact connected correctly. All right, very good. Man, this has been a long time since we started this circuit. All right, let's check the other connections. We have, let's check, R14 should be connected to the F5 output. Let's check R4 first. Okay, R4 should be connected to the base of Q2. R4 to disconnect to the base. In fact, it's connected to the base, so it's good to go. And then I will check the other connection. So okay, and R4 then is connected to ground. So let's see that it's connected to ground, so it's good to go. R4 is good. Okay, so now we're gonna check. R14 should be connected to the, okay, let's check the diodo 2. Diodo 2 is connected to the base of Q2. Diodo 2, the anode is in fact connected to the base, and then the cathode is connected to the anode of diodo 9. Yes, in fact, it's connected to that. So you can see right here, and then this is going to ground. The diodo 9 center diodo is connected to ground, so it's in fact connected correctly like that. So we have diodo 9, the anode of diodo 9 should be connected to the cathode and the resistor 14, R14. Let's check that out. It's in fact connected correctly, so it's good to go. So R4, I already checked that, is good to go. This is fine. So now we're gonna check this one here, this connection. All right, let's see. Let me save it just in case. Yeah, it looks a little weird. I know it looks a little weird, but I think it's fine as longer the connectivity, the connections are correct, and the circuit function, it behaves correctly. It's fine with me. I mean, it's fine with me. Also, the creepage rule. All right, now we're gonna check the. Well, I forgot to check R14. Yeah, it's in fact connected to F5, fuse, 5. So it's in fact connected correctly. All right, and well identified also. All right, let's continue here. So we have, let's start with the R9 should be connected to the other R3. Basically, they are connected together. So let's check that out. So this R9, let's see. The body, my body, is in fact connected here. My buddy, my friend. Let's see. Okay. Oh. Okay, let's see now. R9. So it's feeding by this R19 is the one that is going to supply that voltage, and it's going to be regulated by the diodo, center diodo. It's going to be regulated, so R3 and R9, they should be connected right here. If I check right now, it's in fact R4, sorry about that, R3 and R9. This is R3. This is confusing here. I need to move this. I think it should be here. There you go. So R3 and R9 are sharing the same voltage. It's right there, the connections. And then R9 is connected to a meter of Q4. R9. So let's see that. Yeah, it's in fact connected to the emitter of Q4. There you go. I'm happy with that. Now let's continue checking here. So let's check the LED tree. The collector is connected to the collector is connected to the cathode of the LED tree. The cathode right here. The collector is connected to the cathode, and then the anode, it should be connected to ground. Let's check that out, and it is in fact well connected. All right, cool. All right, we have R12 is connected to the base of Q4. R12. Okay, there you go, right here, and then it's connected to ground. 56K. There you go. Okay, hold on, let me do the test. Okay, R12. This is R12. Why is it so weird? Let me see. Hold on. Yeah, it is R12. It's weird. This should be placed in another area. You should place it here. I think it's better like that, so I don't get confused. This is R12, and then it's connected to ground. We got it connected to the base, and then we're gonna have the diode 4, the 1N4140A should be connected there. The anode and the cathode should be connected to the R23. Should be connected to R23. Is in fact connected like that, and then we're gonna have the diode 10. It's connected to the diode 10, the anode, and then yeah, it's in fact connected. And then we're gonna have the cathode connected to ground. The cathode is going to be connected to ground. Let's check that out. It's correct. All right, we got that. Maybe Mr. ST is gonna maybe do some changes here. I have the connectivity. Now I'm gonna check the top connection. It is different. I noticed that it's different. Maybe we can do some configurations here, different configuration. I don't know. Maybe we can leave it like that. I don't think it's a big deal. As long as it's correct, the connectivity is fine. I'm happy with that. It's okay. Okay, so yeah, the resistors that they were here, that I already removed them. We don't need them anymore. So we only have one ground. Is this one right here? We only have one single ground. Maybe we can make this trace a little thicker. Probably, I think it's the best choice if we make this trace a little bit thicker. I think it's the best choice. This is 0.50. This is 0.60. Let's make it a little thicker. There you go. A little thicker, and this I can fix this and make it look nice. There you go. That's a lot better. And let me see, C1. Let's select C1. I think this is the separation here is a lot better. Try to keep the traces away from each other the best we can. I think I can place a reinforcement here. Let's do that. Okay, this is 0.60. Whoa. Let's go 0.60, man. Come on now. I think in general all the traces should be 0.60. I think this is the best choice. 0.60. This is 50. Let's do the 0.60 of them. And we don't want the trace to be way too thin, right? All right, let's do that. Let's do the 0.60. This is 0.60. No, 0.50. Let's do the 60. There you go. That's fine right there. Okay, I see that. I see something here. There you go. And then I'm gonna make the fancy termination, basically. Okay, let's go down. Should I make it larger? I think that's fine right there. Let's see. Oh yeah, there you go. Really nice, really nice. Oh, I see some anomaly here. Okay, let me see. Should I go up? Let me see. No, I think it's fine. This is 0.60. Okay, 0.60. That's fine right there. Okay, now I'm gonna check the top part of the. Hold on, guys. I think I can make this nicer. So they will have the reinforcement. C2. Okay, hold on, guys. Let me see. Hey, there you go. That's fine right there. That's fine right there. Okay. All right. Now let's go to the top to check the connectivity. Sorry about that. I'm coughing. Okay, so I already checked this. Let's check the other one. The top circuit. Oh yeah, I forgot to explain you what the hell I'm doing here. Yeah, I forgot to explain you guys. Okay, this is basically, I gotta keep mention that because maybe you see in this video for the first time and you see what's going on, what the hell he's doing. Basically, this is a fuse blow indicator. Basically, the fuse. One example. This is a unregulated power supply for Class AB audio amplifiers. This is a prototype. For now, we're gonna call it prototype because we're just gonna order a few for testing. So, if we have the fuse blow indicator, this will have the fuses, the fuse holders, so you can protect your amplifier in case something happens. You know, the fuse is just gonna blow, and no further damage is going to occur or happen. You know what I mean. And then we're gonna have this circuit. One example, you are listening to music. Let me close the key. I had the key A and key B. I'm gonna turn on the simulation. Okay, the simulation is on right now, and this is the 2-bridge rectifier with the jumper options. Actually, you can select one single bridge rectifier or 2-bridge rectifier on this circuit. So right now it's on the circuit. You can see the LED 5 and LED 2, they are off. They do not have any lighting. It's not on right now. So one example, the fuse 3 and fuse 4, let's say that for some reason it was really hot day and the amplifier was getting really hot. For some reason the output transistor, they get hot and they short out. For some reason they short out, maybe some other reasons. Maybe you went stupid turning on the volume too high and it was draining a lot of current and the fuse blow. So one example, if that happens, you will see it as a view reference, so you will see it on the PCB. So one example, I'm gonna press the A on the simulation, and you will see that the LED 5 turns on. That is telling you that there is a failure on the fuse. The fuse is open, so you will see, oh, okay, I have a problem with my amplifier. Something happened with the amplifier. So let's check that out. So we have the fuse indicator. So that's the fuse fuse 3. Sorry about that. Fuse 3. The same thing will happen with the other fuse. This one here is the LED 2. If I press the key letter B right here, I'm gonna activate it. I'm gonna open this switch. Just to let you know, it's just simulating that the fuse blow. The fuse blow right now. So I'm gonna press the key, and you will see that the LED turns on, indicating that the fuse blow up. So that's what we're trying to do. That's what we're trying to do on this PCB. You will have the fuse blow indicator on this PCB for power supply, unregulated for audio, Class AB audio amplifiers. So let's continue checking here. I gotta make this video a little longer, so for reference, probably it's helping me a lot, because when I upload the video, I sometimes watch my own videos And I noticed that I made a mistake that I needed to address and fix. So it helped me a lot to upload this video, so I can watch it later and be like, okay, I did something wrong here. I think I can do this better. You know, it helps a lot. All right, now I'm gonna continue here. Let's check the connectivity. Okay, we have R13 is connected to the main power. There you go. R13 is right here. R13. All right, so we're gonna have the center diode is connected. The D5 center diode is connected to the anode, is connected to ground. Let's check that out. Okay, let's see. Diode 5 is in fact connected to ground. Let's do the test. Diode 5, there you go. It's connected to ground. Perfect. So we check that out. It's good. And then we have the R13 should be connected to the cathode of that center diode and is in fact connected correctly. All right, cool. We got that. All right, let's see the resistors. We got R10. It should be connected to the cathode. R10. So let's see that. I think this is the one. This is the one. You can see the R10 is connected to the cathode. Good to go. And is feeding the emitter of Q1. There you go. Good to go. All right. So let's continue the test, checking. All right. We have R11 should be connected to the base of Q1. R11. There you go. Right here. R11 is connected to the base of Q1, and then it's going to be connected to ground. So that is in fact correct. So we had the diode 1. It takes a long time. I know, guys, it takes a long time to do this. Maybe it's going to be boring, but this is the way you have to do. I mean, this is the way you gotta do it. I mean, you gotta check it. You gotta check it many times. Many improvement we did on the PCB. Many improvement. All right, let's see. So we had the cathode or diode 1 should be connected to the base. The cathode, el cátodo. I think I should show you that right now, guys. I misspelled that. Diode. Okay, we got the anode is right here. You see this on this illustration right here? We got the anode, we had the cathode. So you gotta keep that in mind. You can see there's a silver line in the front in this edge of the plastic encapsulated diode. This is the cathode and this is the anode. So just, you know, this is the symbol. The anode, the cathode. I gotta keep. It's a best choice if I show you that, right? So maybe you are learning electronics. Probably this video will help a lot. I should not show that. It's okay, guys. All right, let's continue here. So we had the cathode is connected to the base of Q1. Is in fact correct. And then the anode is connected to the cathode of diode 6. It's connected to the cathode of diode 6. Oh, there you go, guys. This is excellent right here. Okay, you see that? This is the ground, and the anode of diode 6 is connected to ground. There you go. The R16, it should be connected to the fuse F3. All right. So let's see that. It's connected here. It's going to be connected to the cathode or diode 6 center diode. Yep, there you go. There you go. So this is already complete. This checkout is complete. Now let's continue with the other one. I think this is a lot easier. This one is easy. Okay, let's see that. Let's check the first component, R7. Let's check R7. Okay, we got R7. Our friend R7 is right here. It's connected to this R13, sort of like a voltage divider. Look like a sort of like, okay, the output of this, the output. All right, so the output of R13, the output. Okay, we got R13 and R7 is connected right here, and then it's going to feed the emitter of Q3. It's gonna feed the emitter of Q3. There you go. It's good to go. All right, let's check the other one. The LED 2, the anode is connected to the collector. LED 2, the anode is connected to the collector. There you go. All right, we got that. All right, let's see. The RA is connected to the base. Is connected to the base right here. And then the cathode of diode 3 should be connected there too. So we got it. It's connected like that. So RA, did I check the RA? Let me see. RA is right here. RA is connected to the base, and then to ground. There you go. All right, we got that. All right, let's see. R27, there you go, should be connected to the anode of diode 3. We got that. And last connection is diode 7. This is the 4.7 volts center diode, should be connected there, the cathode, and the anode of the center diode 7 should be connected to ground. There you go. So all right, it's good to go. All right, I'm gonna stop the video and I'm gonna continue checking the connectivity just to make sure we got everything correct, the top and the bottom of the fuse indicator. All right, that's it. I hope you like this video, guys.